Okay, we're going to work on some fractional abundances to determine atomic mass. Now in this problem, you have two different isotopes of chlorine, chlorine 35 and chlorine 37. Here's the actual mass of chlorine 35, and here's the actual mass of chlorine 37. Chlorine 35 has a percent abundance of 75.77, and chlorine 37 has a percent abundance of 24.23. We're going to multiply, whenever you do atomic mass, you have to multiply the mass of the isotope by the fractional abundance. Okay, here's the mass of my isotope here, and here is my fractional abundance. I'm sitting at an angle, so I'm trying to work here. Okay, so now what you want to do, we're going to take our 34.96885, lots of sig figs there, and we're going to multiply it by a fractional abundance, not percent. Let's move the decimal point 2 times this direction. So 0.7577. We're going to add it to this mass of the isotope, 36.96590, and multiply it by the fractional abundance, which is 0.2423. Okay? Now we multiply these two. When you multiply these two numbers here, we get 26.50. We can only have 4 sig figs, so make sure you only have 4 sig figs there. We're going to add it to this here. When I add these two, multiply these two together, I get 8.96. Once again, I need 4 sig figs, so 0. Okay? Now, I add these two together. I'm going to need 2 digits after my decimal. So when I add these together, I get 35.46, which is very close, if not the actual atomic mass of chlorine. Remember, mass of isotope times fractional abundance. Let's try another problem. Let's see here. There we go. So, this time we're calculating bromine. So bromine has 2 isotopes, with the first having a mass of, up here, 78.918336 AMUs, and occupying 50.69%. So we're going to multiply this first one, 78.918336, by the fractional abundance. Move this 2 times this direction. So 0.5069. We're going to add it to this. This is my isotope 1 here. We're going to add it to isotope 2. So I have 0.916289 multiplied by this fractional abundance, 1, 2, this direction, 0.4931. When I multiply these two together, let's see if I can get a little thicker here. When I multiply these two together, I get 40.00. When I multiply these two together, I get 39.90. When I add these two together, I get 79.90, which is the actual atomic mass of bromine. Again, 2 different isotopes, and then you're going to multiply the mass by the fractional abundance, mass by fractional abundance, and add those 2 together. Let's try one more and see how we do here. Oops. Okay, I'm going to give you a second to try this on your own. Now this time though, unfortunately, they didn't give you an actual average mass. They just gave you this mass number. When they just give you the mass number, go ahead and use the mass number. It's probably close enough as it is. So take a minute and work on this. Okay, let's look. We have rubidium 85, so we're going to take 85. We're going to multiply it by the fractional abundance of 85, which is 0.722. Then we're going to add it to isotope 2, which is 87. Multiply it by 0.0278. When I do this, because I only have 2 sig figs there, this becomes 61. I only have 2 sig figs here, so this becomes 24. When I multiply these two together, I get 61. I multiply these two together, I get 24. And it becomes 85. And the actual atomic mass of rubidium is like 85 point something, I can't remember. But anyway, this is how you do fractional abundances. This is also how you're going to work on your Pinium lab. If you look at your Pinium lab, okay, let me get rid of this for a second. On your Pinium lab, you have, I'm just going to get rid of this, you know your percent abundance. You know the mass, the average mass of the pennies and one isotope, and you're going to add it to the percent abundance times the mass of the pennies in the second isotope, and that's how you're going to get your average atomic mass of Pinium. Have any questions? Email me. Thanks.